Um, the lecture for today is Big Data and Artificial Intelligence. So I have added artificial intelligence, so not just big data, yeah. So big data and artificial intelligence. So we are going to discuss first about big data, the definition of big data, and IR 4.0, industrial revolution 4.0, artificial intelligence, machine learning, examples of projects that are developed from big data and large language models. So like what is big data actually kan? So people talk about big data, but what does big data mean? So the simplest definitions of big data depends on the size of the data and the complexity of the data. So if the data is large and complex, so that can be considered as big data. How to say a data is big or small? So you can look at here, the main feature of big data is that this data will not fit in the traditional software or traditional or on your machine. Okay, so the main feature of big data is that the data is so huge that it does not fit your computer or your laptop or your machine, right? So that is the simplest definition. So so we understand that now because of the internet and because of the internet especially, there is uh, data comes in from all over the place. And so data becomes big. And because of that, it directly and indirectly affects the public health lah. There is, one paper by Khoury and Ionidis in 2014. So what are the challenges when you work with big data? Okay, so you might ask me, okay, if your size of data is 20 megabyte, is that big enough? If the data can fit your computer and you can run it, very easily on your computer, still it is considered as small data. But if your data is, even though it has like maybe 200,000 observations or 400,000 observations, if the data is like 20 gigabyte, okay, 20 gigabyte of data, and your computer only has 8 gigabyte of RAM, then of course it does not fit your computer. You cannot run it. So that can be considered as big data. So the problems of big data is that number one, um, how you capture data. There will be different sources of data. There will be different format of data. There are different connection that you require because you have different databases. You have data on the cloud, and then you have Amazon Cloud. You have Google Cloud. So how to capture all this data, and after that, how to store this data, because the storage must be huge, and then data keeps coming in. Scalability means that the data gets bigger and bigger and bigger and bigger. And then how to analyze this type of data is huge. It's on the cloud. How to search for data, how to share the data, how to transfer data from cloud to your computer, from your computer to cloud, things like that. And then how to, visualize the data, how to query the data, how to update your data, and also the information privacy. So sometimes data, this huge data has personal identifier. they have locations of where you use the data and all that. So these are the challenges when we work with big data. So this is very important. There are four V of big data. Number one, the volume itself. So big data means data in big volume. Number two, velocity. It means that data transfer is fast or is quick between computer and computer, or between computer and cloud, and so on and so forth. And then variety. It means the data can be in different format. It can be in a text format. It can be in image. It can be in sound. Variety. Um, and also veracity. It means that the data is complex. Is complex. So these are the when you define big data. This is how you define it. It has to have four V: volume, velocity, variety, and veracity. And then uh, how does big data relate with Industrial Revolution 4.0? Um, the fourth industrial revolution occurred in the middle of last century, kan? So there is physical advancement, digital advancement. There is also biological advancements. And because of that, and also we are now in the interconnected world. Because of that, um, we have data coming from robots, from augmented reality, coming from simulation, coming from Internet of Things, coming from finance, coming from you know from hospital, from all over the places. So that is one implications of the fourth industrial revolution, and that leads to big data. And next, what is AI? What is artificial intelligence? Artificial intelligence is simulated intelligence in machines. It means that we try to make a machine to make the machine as intelligent as us. We try to teach machine to able to think like human, or to make decision like human, right? So that is the a very crude definition of artificial intelligence. So there are different types of artificial intelligence. Number one is the um, artificial intelligence in terms of how you analyze data through machine learning, for example. And number two is you have data through speech. So you can analyze speech. That can also be a method to develop artificial intelligence. You can also train your computer to scan images, and then recognize something, and then make a diagnosis. For example, you can train the machine to scan the mammograms, and it will tell you what is the probability of this image belongs to a cancer patient. Or you can submit recording of cough, and then you can train the computer to diagnose whether that cough too is a TB cough, or COVID-19 cough, or cancer cough, so on and so forth. And now we have recently people are excited about large language model, using which is a branch of NLP, natural language processing, so that we can type, and we can ask questions using ChatGPT or using Google Bard, and then you get answers from Google Bard or from ChatGPT. So those are basically how artificial intelligence work. So and then you have also machine learning. What is machine learning? Machine learning is is the algorithm or the model or the algorithm or the model or the techniques on how to train a machine uh, so that it can become intelligent, it can become smart, you know. So artificial intelligence is a concept. So how to train a computer or machine to be intelligent? One way is through machine learning. So you have supervised learning, you have unsupervised learning, and in supervised learning, you have regression when your outcome of interest is continuous or numerical, and you have classification problem when you have the outcome of interest in categorical, like yes, no, died or alive. You can make prediction using machine learning. So because the outcome is categorized, it is a classification problem. You can also have unsupervised learning. It means that uh, you know, uh, you are trying to find patterns using machine learning. So how to run or how to train or develop artificial intelligence using machine learning. So first you have data. Okay, you have data. Um, Maybe let's say we want to predict cancer based on mammograms. So we have mammograms images data, and then you have um, for each of the data, you know that this data belong to cancer, this data belong to normal. So you got that raw data. And then you apply pre-processing to data. It means that from the image, mammogram images, you resize it, you adjust the orientation and whatnot. So that is known as pre-processing phase. Then you got the prepared data, and then you run or train the model using certain algorithms. Okay, right? So whether it's for example, if you are using mammograms as your data, then you might want to do convolutional neural network CNN. If you got time series analysis, then you can use recurrent neural network. If you have structured data, then you can use support vector machine or random forest, so on and so forth. So there are hundreds of models that you can choose on to train your data. And after that, if your model has very good accuracy, you want to deploy the data, and then can be used as in the mobile phone or in the web application, so on and so forth. So we have another one, another methods called as deep learning. So deep learning is a more specialized machine learning methods where you have many layers, okay, many layers, and then usually uh, we use deep learning when we deal with unstructured data. What do we mean by unstructured data? Unstructured data means data that are not in regular tables. They can be images, sound, or what sound, images, or time series analysis. So that can be data that are useful using deep learning methods. Oh yeah, also genomic data. Genomic data, you have like raw data, and then you can clean your data from genomic data. You get all the uh, um, genetic makeup, and then you can do some feature extraction, do modeling, and then evaluate the accuracy. Yeah. Um, Examples of deep learning artificial intelligence models. One is image recognition model. For example, Facebook use a facial recognition software or system. I mean, if you remember Facebook kan, if there is picture or photo in your Facebook, the Facebook can identify the photo kan. So that is one examples of how Facebook used deep learning for image recognition. Self-driving cars, Tesla and everything, uh, it can analyze things in front of the car, and it will tell you, okay, this is tree, this is people. So, self-driving cars. Speech recognition. When you talk to your phone, when you talk to your computer, when you talk to your Apple iPhone kan, Siri, it will recognize your voice and it can understand. So that is another uh, product from deep learning AI. We also have Google Brain, Amazon Alexa, Google DeepMind, IBM Watson, so on and so forth. So artificial intelligence is, the big concept, and then how you uh, analyze data to come up with AI. You use machine learning, and one branch of machine learning that is very popular now is deep learning, where you work with unstructured data, images, sound, genomic data, so on and so forth. So when you analyze your data, sometimes you will ask yourself whether you want to do statistic or you want to do machine learning. Even though there are overlappings between the two, usually machine learning is more, is a set of steps or rules fed by user where machine understand and train by itself. Okay, so you let the machine learning to run on itself using some kind of algorithm. But in statistic, it is a mathematical concept, and then driven uh, by the content subject or subject matter expert. You have models that you think are important, and then you want to estimate, to make some estimation. That is statistics. Machine learning is you let the machine to run your model to learn on its own. And then machine learning is used for prediction. It is not used to understand the interaction between variable, solely for prediction. But statistic is, you want to find relationship between data points and between covariates and how it affects the outcome. Machine learning use mathematics and algorithms, and of course hardware, GPU and CPU. Statistic use mathematics knowledge. So statistics is more to math and stat domain, and machine learning is more to words computer science domain. So this is one paper where where you can look at, or when you can read a review of artificial intelligence in healthcare. Not a difficult paper. So it tells you how you can use artificial intelligence in healthcare. This is quite an old paper in 2015, where the author talks about how genetics can make use of big data technology. There's also, you can do sequencing. You can also analyze social media data. You can analyze cardiac imaging images, so on and so forth. This is, machine learning analysis using heat map and dendrogram for genetic data. And then at University of Pittsburgh, they have used data as big as 5 petabytes or 5 million gigabytes. Okay, so they use that data to make prediction for breast cancer. And then they use public databases, TCGA and Metabrick, databases um, to help them with prediction. And this is, where they can download or where you can download the data sets. Data sets are huge here. So this is one repository you can go to if you want to download the data. This is also big data showing the number, showing the patterns of tweets. Tweets sekarang tak panggil tweet kan, kita tak panggil Twitter, kita panggil X kan. So between September and October, where they analyzed 826 million tweets and 146 million geolocated data across 1,300 counties in the US. In the US, right? So they evaluate stress and hostility. They look at the health and attractiveness and job and all the curseword and all that. So they combine with the CDC data and US Census data. So it's huge data, 826 million tweets data from 146 million geolocations. So they can come up with the predicted AHD mortality. What is AHD? Acute heart disease ke apa dia? Cardiovascular disease. This is satellite imagery, high resolution real-time data. So they use data from I think geography data, like vegetation index and whatnot. So by using the satellite data information based on satellite, maybe vegetation index, ketinggian dan sebagainya, they were able to identify area with stunting rates, okay, all over Nigeria. And this one, they use big data to discover diagnostic and therapeutics for GIT and liver disease. So what did they use here? So they use this motility data, NASH, this motility variables, NASH variable, pancreatic cancer, IBD, colorectal cancer. So they combine the genetic data, the electronic health records, patient reported data, and then they can come up with some kind of prediction. This is artificial in precision cardiovascular, where they use data from electronic health records, EHR. They use social media data, they use genetic data. They can also use wearable technology, jam ke apa kan. So from that, they combine all the covariates or the factor or the variables, and then they use deep learning, machine learning, and then they can come up with some kind of model to predict cardiovascular disease. Right. So this is mammograms. So mammogram, so one image, one patient's one mammograms from mammograms from one patient may maybe as big as 200, 300 megabyte of data, right? So and because the data is in image, you can use machine learning to read the image to identify the patterns, and after that to predict the probability of cancer uh, based on the image that the computer see. So you got this one kind of input, which is the mammograms, and then you have some convolutional neural network. Okay, just a second, yeah. Okay, so okay, you got the mammogram images kan, and then you pass the mammogram images into through some layers. We call that convolutional layers, and then from there you apply the machine learning models. It can identify or it can identify which area might be having cancerous cells, and what will be the probability that the image the computer see is cancer. So it will tell you, okay, 78% probability of cancer, 98% probability of cancer, 85% probability of cancer. Okay, right. So um, so there is okay in mammograms, yeah, no problem. We just discussed that. What is this is another innovation by clinicians, by DeepMind from Google DeepMind. They work together with NHS. So what they did is basically they use um, retina images or CT scan, and uh, from this scan, they develop machine learning models. So whenever the computer see the image, then the computer will give the probability of this image or the retina image or the OCT scan is due to apa ni some eye disease. Okay, if not, usually what they do is the clinician will have to analyze manually, do the scan manually, go and see patients, and then only they can diagnose the eye disease. But now you can bypass clinicians. You can just do this OCT scan in the remote area, for example, and then you feed or you send these images to a computer. Computer will give the diagnosis and the probability of the diagnosis, and then you doctor and the doctors can look at the scan, and if they see patients with high probability of eye disease, they can just go straight and see this patient. So it saves lots of time, right? So okay, this is the paper, clinically applicable deep learning for diagnosis and referral in retinal disease. Okay, just a second, give me 5 minutes. Okay.
Thanks, bro.
All right. Okay. So this one is uh to diagnose lung cancer, lung nodules, and then apa yang mereka buat is, what they did is they have this CT scan images. Okay, CT scan images. So what they did is basically they use the CT scan images, and from there, using deep convolutional neural network, they can classify whether the image to correspond to cancer or not. Usually, what the machine will give is the probability of this image is cancerous, like, okay, 50% probability or 60% probability of this image is cancer. Okay. And what this is Streams, which was developed in partnership with technology company DeepMind. DeepMind ni company from Google. So they use data, patients data, and this patient data can be used to predict development of acute kidney injury. Okay, acute kidney injury. So usually doctors and nurses uh, must analyze hours or days data from patient. Tapi by using machine learning or using streams, they can quickly within minutes identify which patient that are high risk for developing AKI. Right, so you can use machine learning for diagnostic testing, for identifying patients for treatment in oncology. You can use machine learning to make diagnosis based on medical imaging. You can also use wearable data from your handphone, your smartwatch, to make prediction. Okay, so and this is the Singaporean population electronic health records. They combine with clinicians' input, they combine with lab reports, clinical data, and they use unsupervised inference, and then after that they use supervised analysis, and then they came out with graphical model to predict complications. So when you have a patient with this disease, this treatment, this lab report, so they will know whether what is the probability of this patient will have complications. So when they know that, they can quickly intervene patients who are at high risk for complications. Right. So another one is Watson, IBM Watson. IBM Watson is being used in many hospitals now. I think in Malaysia, KPJ Malaysia use IBM Watson. So IBM Watson use more than 300 medical journals, 200 textbook, and nearly 15 million pages of textbook. So they use this all the literature uh, to make prediction on what would be the best treatment for a patient. So for example, you have patient A with this complaint, this diagnosis, and then IBM Watson will make a prediction to choose what would be the best treatment for this patient. Okay, Google has a website, ai.google, where you can look at what Google has done in terms of artificial intelligence. Okay, in summary, big data mean lots of data, variety of data, and you also have to appreciate the difference between artificial intelligence, machine learning, and deep learning. Again, you are the expert. As a doctor, as a clinician, you are the expert in your area. But to work or to make model in machine learning or big data, you have to work with expert in computer science, expert in disease modeling, so that so when you develop your algorithm or machine learning, it will be useful and applicable and effective. Also, you must understand where is the data source, what are the algorithms that you can use, what is the objective of prediction, and how you can deploy your model.